Well, welcome back to Decarb Connect's podcast. And this week we have a kind of a bit of a shift in our discussion pattern because throughout December we were mostly talking about innovation and disruption. And although this conversation about carbon capture is definitely going to feed off that, it's a different tone, different perspective. And I'm very happy to be joined by Craig Golinowski, who is the president and managing partner of Carbon Infrastructure Partners. And before we hit record, we were just talking about the fact that he's based up in Calgary, but Carbon Infra has offices in the States as well. So what I'll actually do is hand over to Craig. You'll give us a bit of an introduction about you and about really how it is that you've come to work in this space around carbon capture. And obviously we're then going to crack on into our conversation about whether carbon capture is the radical middle ground in the energy transition, which is kind of a provocative statement, I think, for many people. So it'll be an interesting conversation to have. But kick us off with, how have you arrived at this point in time, Craig?
Wonderful. Well, thank you, Alex. And this is a great opportunity to be with you on this. So my background is I've been in an oil and gas, investment banker, private equity fund manager my whole career. And a couple of years ago, I had an opportunity to move to California. My wife was going to school at Stanford, and I started hanging around the carbon management department at Stanford, which is part of geology and earth sciences. And I attended a seminar where basically that's the first time I'd really heard, 40 billion tons a year, which is more or less the amount of CO2 that we're putting up into the atmosphere. And it sort of struck me in that moment that, that's an enormous quantity of CO2. The next thought was like, well, what are we actually going to do about this? Because as an energy professional, the problem is a vast one in that, energy touches all aspects of our lives, from fertilizer production, steel, cement, transportation, heat, all these things that are actually really very difficult to change because of thermodynamics and just the basic engineering and sort of laws of physics. And so I just, at that moment in time, I was like, we need to be a part of this. We need to make a contribution as energy professionals to this problem. And so that's where it dawned on me that I'll probably spend the rest of my career working on this problem. And so that's how I arrived at it. So then what we did is we rebranded our firm to Carbon Infrastructure Partners, and we created a private equity fund product with our law firm Kirkland & Ellis in the United States. That is an investment product that's designed to back companies and projects that are enabled by carbon capture and storage in the United States and Canada. So we're taking our skills as energy investors, as private equity investors, to directly back companies and projects that are going to take CO2 that otherwise would have been emitted in the atmosphere, put it into the ground, or in other cases, creating a negative emissions profile and putting that CO2 into the ground. And so that's how we've sort of come to this. And I think we're, the industry, which we can talk about the economic drivers for it, but carbon capture and storage in North America is really entering into a liftoff phase. And it's a very exciting time to see this industry become a real commercial opportunity.
Well, it's definitely one of the tools, one of the technologies, one of the platforms, however you look at it, that also gets the most challenge, most bad press. I know that when you and I were talking about some of the kind of companies you invest in, but also your perspective on it, you talked about this idea of carbon paradox. People listening will have their own views. It's not my job to kind of tell people they're right or wrong. I just want to present these different perspectives around this issue. So talk to me about your perspective on this and this concept of carbon paradox, which I thought was really interesting.
Yeah, well, that's great. So, starting from, primary energy. So oil, gas, coal, nuclear, hydro, wind, and solar. Those are our choices for primary energy. Electricity is not energy. It's just an energy carrier. Hydrogen is not energy. It's an energy carrier. So those are our choices. And today, human beings, we 85% of primary energy is coal, oil, and natural gas. And so that's sort of the starting point today. And when you sort of plot out energy choices, you can sort of imagine a triangle in your mind and put affordability, carbon emissions, and reliability on the 3 points of that triangle. And each of our energy choices are trade-offs, and we're bound on that triangle. So for example, solar panels, very good at affordability, very good on carbon, not reliable. There's night, there's clouds. And so if you wanted to improve the reliability by adding batteries, Now we added carbon emissions because we've got to make the batteries. The batteries are expensive, so we've challenged the affordability side, and we may have added 4 or 6 hours of reliability. So while those points may come closer together with technology solutions, it's actually really challenging to solve all 3 of those simultaneously. And so one of the phenomena that I've observed, and the data would support it, is that where there's gaps in reliability, so in other words, there's a difference in the supply and demand for energy in a particular moment in time, there's something that I've called the carbon paradox, which is that those gaps in supply and demand are met with the highest carbon intensity energy sources. So what do I mean by that? So what's happening today in Europe is there's a gap in supply and demand for electricity. And so coal plants are having to be fired back up, and liquid fuels like fuel oil generators, those are being fired back up in Sweden. Those are also being fired back up in Japan. So we could have had a more reliable natural gas based approach, but we don't have enough natural gas right now in Europe and in Asia. And so there you meet that gap in supply and demand by going downhill per se in carbon. And so you start going back to coal, you go back to fuel oils. And so the carbon intensity of those are double, in some cases. And so that phenomena of gaps in supply and demand being met with higher carbon intensity is what I've called the carbon paradox. So what that means is when you think you're doing the right thing, adding renewables and going down the road, if you're not mindful of reliability, you'll end up actually having the same carbon emissions or potentially even more carbon emissions than you would have expected. That can also be manifested in the following example, which is, if something would have otherwise have been manufactured in Europe, but now because electricity is basically unaffordable and that production moves to China, the Chinese grid is more than twice as carbon intensive as the European grid. And so every time that something that otherwise could have been manufactured in Europe gets moved to China, you've just doubled how much CO2 emissions come out of that product. And so this is where things like reliability and affordability are absolutely critical to get right, because if it just turns out that Europe deindustrializes and all that production moves to China, the total amount of emissions in the world will probably go up.
So you've sort of explained what the carbon paradox is, but how does this then come back to CCS as the concept of being the radical middle ground?
Yeah, well, the reason it's a radical idea is because what it says is that today I think there's this misguided, and it's basically, I really believe it's incorrect, that the solution to emissions is to eliminate the use of fossil fuels. And I just don't think it's possible to do that anytime soon, if ever. And so carbon capture and storage is controversial because it requires people to essentially admit that we'll continue to use fossil fuels, and that by using fossil fuels, we can actually reduce emissions and solve some of the emissions problem, at least with the fossil fuels that are partnered with carbon capture. And for a lot of folks, that's, I think, a very difficult thing for them to say that they accept. And so, that's fine. We have there doesn't have to just be one view on this particular issue. But I think so for us, the sales pitch per se, as we think about it, is, okay, well, what can we produce from oil and gas and coal that are useful energy products? So electricity, hydrogen, ammonia, methanol are all energy carriers where we can produce that, put the carbon dioxide into the ground, and when the consumer actually uses that energy, the emissions at the point of use are eliminated. So with electric vehicles, producing that electricity with carbon capture allows that electric vehicle then to produce the transportation benefit without emissions. Hydrogen, we can produce industrial heat, run fuel cells on trucks, manufacture renewable diesel. We can make a variety of aviation fuels with hydrogen. And so producing hydrogen at quantity can be done with coal gasification and natural gas, and so on and so forth. And so these are the energy products that we can produce in the here and now based on basically readily available technologies. And so I think that's incredibly exciting because it's actually an answer that we know how to do today, and we could scale up today with the right commercial structures.
When you look at sort of energy needs, energy requirements, what's your sense of what proportion is viable? What's the right economic amount to attribute to renewables?
Yeah, well, that's a good question. So I suppose I come at it the following way, which is if we had a sort of a carbon price across the entire economy, and we set that price at $100 a ton, or that's probably about what the number should be, US dollars. We don't have to answer that question from a central planning perspective. The market will just figure out what the optimal answer is to it. And then we can discuss, is that politically possible in the United States, for example? It probably isn't. So what actually has been happening is you have these carrot style policies that creates incentives for wind and solar and batteries, and incentives for carbon capture. And so they're less efficient because, basically you have to have some political process to arrive at these numbers, and it's picking winners and losers. And, no disrespect to the professors and the government people, but like picking winners and losers is really difficult to do. The market's the best way to do that. But anyway, so that's how I started this. But we are where we are. So when you look at certain markets like California, like Texas, both of those have achieved, 23, 24, 25% market share of intermittent wind and solar. And both markets are experiencing stress on the grid. And so, the requirement for either batteries to fulfill peak in California, the duck curve problem, or in Texas, I mean, the winter blast that took them out last winter, the batteries definitely can play a role to increase that market share further. But the evidence today is that once you've hit 23, 24% market share in those two case studies, you're running into problems. In Europe, in the UK, I mean, basically the UK today is in quite a lot of trouble, to be honest. Like this winter, there's a decent chance that the UK in particular and the continent basically run out of natural gas before the winter concludes. And when you look at why that is, in the UK, renewables, I may have this number a little bit off, but I think it achieved roughly a 40% market share. And so then you've got the balance is basically natural gas. And the coal in the UK has essentially been removed. So in the last 8 years, 22 gigawatts of coal has been retired out of the United Kingdom's energy mix out of a 40 gigawatt electricity market. And so now you got this situation where you got variable wind, and the North Sea, for whatever reason, in August and September had terrible wind production. And so then the entire electrical system had to rely on natural gas, but there's only so much natural gas storage in the UK. And so like anything, if you've got a volatile rate and a certain amount of inventory, basically the inventories today are run down, and there's a possibility that the UK runs out of natural gas before the winter's over. So it's kind of what I'm trying to say there is that, at 40% market share on renewables, that's one piece of that puzzle. But the other side of it is that now you've got the base load natural gas system, but the storage, the amount of energy storage behind that natural gas system hasn't been expanded. And so as you've taken the coal out over an 8-year period, which frankly is like a moment in time from an energy perspective, I mean, 8 years is just like a flash in the pan. There's an incredible additional volatility that's been added. And so each jurisdiction is going to be a little bit different, but the basic problem of volatility and storage to offset that volatility, that's the fundamental problem with this how you move off of coal and add renewables.
It's been a long known argument, hasn't it, for renewables, that we need to solve the issue of long-term storage and so forth. And then you have these old school fossil fuels and the opportunity of carbon capture. I guess one of the challenges there is really around perception and the nature of the evidence at the moment for carbon capture, right? Which is that the anxiety around it. For some people, the anxiety is, well, why should XYZ sectors get to make money out of a problem they created? For others, the anxiety is more, do we have the evidence that this kind of sequestration is really permanent, is that it brings that kind of permanence to that storage that we need? I wondered what are your thoughts on perhaps those kind of questions around carbon capture at the moment?
Mm-hmm. Yeah, I think those are very good questions, because I think my view is in the coming years, we're essentially in a 5-alarm energy crisis. So we're going to have, if the United Kingdom runs out of natural gas in March, that anxiety around freezing and having like perilous danger, that's going to right the ship here a little bit, which is that I think there's a lot of perspective that energy is like somehow cares about how we feel about it. The energy system doesn't care how you feel about it. It just doesn't. So the physics of it, the chemistry of it, the thermodynamics of it are what they are. And there's no real way to sort of avoid those basic engineering problems. So I'd make that point. The second point I'd make is that, at the end of the day, the permanence of storage of CO2 in the subsurface has essentially been proven out in North America. There is long, like multiple decades of this process being shown to be effective. And so, the way to just think about it in simple terms is the carbon was in the ground in the form of fossil fuels. And so we're just putting the carbon back essentially where we got it from.
We talked before we came on air about the kind of productive tension around a whole range of decarbonisation tools for all sorts of reasons. But in the space of decarbonisation, you also have the added kind of perspective of those that see good and bad actors, don't you? And with good and bad actors comes the sense of trust and perception, not just evidence and data. So I think it's partly how does that get communicated to an audience that doesn't sit and read geological data, or whatever else.
Well, I think what's going to be interesting is just turning that around a little bit. And you may find this a little controversial, but I think that the renewables industry and renewables proponents will actually have some tough questions to answer as the energy crisis in Europe basically degenerates. So I think there is going to be some tough questions as to why is this happening? Like, why is natural gas $30 a BTU? Why are we having fertilizer shortages? Like, what is going on here? And I really believe that there's been a incorrect emphasis or an insufficient emphasis on reliability and energy security. And so I guess I would just turn that around a little bit, which is I actually think there's a lot of heat coming to the basic discussion that's happening right now by the general public as they open their heating bills and electricity bills, and rightly so. And so I think that we will be forced to answer some of the questions around the acceptability of carbon capture more in in sort of a crisis environment. And I think that, and that's fine, that's fine if folks who are quote unquote on the other side of this debate are reluctantly accept carbon capture, and they're just like, well, we have to do it because it's just reluctantly we have to do this. I can live with that. It's fine, but I do think that the basic framework here is one where we've experienced a decade, if not more, of a time of energy abundance, of a time of real energy affordability and energy security. And that's 180 degrees the other direction today and over the coming years, because one of the things that's happened is, pension funds, endowment funds, institutional investors will not invest in oil and gas production. Just as a matter of policy, many of the European pension funds are basically will not touch oil and gas investment. And so what we have an energy supply problem that's a very serious global problem that's underway essentially as we speak, which is that even though the prices of coal and natural gas and oil are going up, there's no additional supply projects coming online or being proposed or even in design. So, we're going to have this trouble where we're going to have to make some tougher decisions around how does energy supply get increased? What is a sustainable way for that to actually happen? And to be honest, groups like oil and gas companies and others, they're going to have to hear that the product is an acceptable product. Otherwise, no one's going to invest in more production. And so one of the other things that we're seeing today as well that's related to this is that, as coal prices go up, monosilicon and polysilicon prices are going up. So the basic building blocks for solar panels are getting expensive really quickly because solar panels are made out of coal. Wind turbines are heavily materials intensive. So as steel prices go up, wind turbines are going up. Lithium prices are skyrocketing. Copper prices are skyrocketing. You need a lot of diesel, a lot of electricity to process minerals. So as energy costs go up, those minerals are more expensive, which make the batteries go up. So this whole idea that higher oil and gas prices will create a substitution towards renewables. I don't think that's correct. The thermodynamics of it are say that that's not correct. And we're going to live that here where everything's going to be more expensive. And so we're going to have to figure out like, okay, how do we get the most bang for our buck, both in terms of energy supply and the most carbon efficient way of creating that energy supply? And so those are going to be a little more nuanced and sophisticated arguments than perhaps the last decade's set of arguments.
So CCS is one particular tool, one particular answer to that. What's the kind of capability that you think is needed? And I guess we'll look particularly at the North American market, because the thing about, as we all know, the thing about the European market is that we're much more focused, have to be much more focused on offshore, partly due to land use and heaven knows what else. But tell us about North America. What's the kind of capability that's needed there?
So from the perspective of storage capability, the subsurface has an incredible ability to store carbon dioxide in the subsurface. And that can be done in two basic ways. The first is what we call geologic storage. So that's where CO2 is injected in a fluid phase. So you compress CO2, it'll turn into basically a fluid. And then that can be pumped down into the ground, let's say 1,200 meters, 2,000 meters, 2,500 meters deep, into formations that we call saline formations. So that's brine water. You can't drink it. It's radioactive. It's got lots of parts per million of heavy metals and stuff like that. So it's 2 kilometers in the ground. You inject it into the ground, and that CO2 it dissolves into some of that water. It binds with those minerals. It basically stays there permanently. So that basic approach, there is an opportunity to put thousands of gigatons of CO2 into the ground in North America. The second approach is in depleted oil and natural gas formations. And that's where I think there's an incredible opportunity as well. So the natural gas fields that we deplete and then produce off that gas, we know those are contained structures. We know the natural gas was stayed there for millions of years. So we know it's a good tank per se. And so, we can, the pore space that's available to, it had natural gas in it. That natural gas has been removed. And so there's an opportunity to refill those storage caverns basically with carbon dioxide. And so that's what the North Sea is likely to do as well, is put that back into those depleted gas fields. And so there's an incredible storage capability there as well. So basically the subsurface is not the governing problem at all. The challenges with carbon capture are the capture equipment is big, industrial, energy intensive equipment. So the gas separation work is just it's not up for discussion. There's a thermodynamic set of energy that's needed to separate CO2 from the exhaust gas from a combustion process. And so that requires large pieces of equipment to do that. That costs money and it costs energy. So it doesn't come for free, and you can't just sort of imagine these problems away. But in any case, additional, like any industrial process, once we actually start working on this stuff and ramping it up, scaling it up, cost will come down and we'll get better at it. And then the sort of the bigger problem, the one that's not really really easy to solve, is to the extent that CO2 has to be transported from where it's captured to where you're sequestering it. Building pipelines and moving CO2, that's just a challenging proposition because it's just expensive to do that. And folks like the Sierra Club and others, if they take the position to challenge that, then those folks are directly responsible for those emissions happening when they otherwise could have been avoided. So I just want to be precise that the environmental groups that are attacking carbon capture, they're basically part of the problem because there is no perfect solution to any of this stuff. And the CO2 conference I was at in Texas, we get, one of the presenters was a environmental lawyer, and she was just going through all these various activist groups that are starting to ramp up funding to start attacking carbon capture and attacking it from an administrative law perspective, a regulatory perspective. And so, you run into this situation, and well, it's one of the things we write about a lot, which is that there is no perfect solution to energy and emissions. The solutions that we have that we can actually execute on today, we just have to do those. There's an urgency to this because CO2 accumulation in the atmosphere is like compound interest. Like, if we don't work on it today, like if you don't start saving today and you're like, I'm just going to start saving when I'm 60, you lose that time period that you otherwise could have worked on this. And so because it's an accumulative problem, it's actually incredibly important for carbon capture to happen today to allow technology progress to continue on. So things like small reactors and improvements in batteries, like those things are going to take decades before they really can move the needle on emissions. And we've got 8 billion people growing to 9 billion people in the coming decades. So total energy demand is only growing. So my concern is that in a decade, we'll be sitting here at 45 billion tons or 47 billion tons in a decade. And then when I'm, 20 years older, we'll be at closer to 55 or 60 billion tons. Like that's the problem we have to actually address, which is that emissions are actually growing. And so anything we can do that's like proven, that's viable today, we just need to do it. And I'm particularly concerned to hear that there's certain groups that are ready to fight on CCS, and it's terrible.
No, I don't think I know any industrial client who is only looking at one thing anyway. It's not like this, no one's saying CCUS or any of those technologies is the single answer. Everybody is having to look at a serious portfolio ranging from renewables through to this, but also looking at different processes that actually kind of prevent the emission to begin with. This is all going on as a kind of quite a rich layered tapestry, isn't it?
Yeah, that's right. And where I do find though, when you start getting to the root philosophies of certain groups and certain ideas, it's around this idea that the answer is eliminating fossil fuels versus living with fossil fuels. And that's our perspective, is that when, on our website, our first thing when you come right onto the website is what we're saying is investing across the carbon life cycle. So we don't, we just sort of view carbon, the molecule of carbon dioxide as no different than you're exhaling carbon dioxide right now. The lunch you had today, your metabolic process and how your furnace works, those aren't that substantially different. And so this idea that that there's no way to live with CO2, that I don't believe in that. That's not how the Earth works. In my view, it's just not how the Earth works. The carbon cycle on the Earth, there's a natural process that we just sort of live with. And so, anyways, I guess what I'm trying to say there is that when you peel the onion layers back, oftentimes there are those who just have a hardcore view that eliminating fossil fuels is the mission, versus perhaps a more of a practical portfolio approach where you're saying, look, we need to target the GHG emissions. How can we do that and still maintain our industrial system? How do we maintain our lifestyles? How does the 3 billion people that basically have no access to energy in the world, how do they get some energy? How are they going to do that? And I think that's a richer conversation. It's a more nuanced conversation. And it's one that sometimes is lost, I think, in a bit of the rhetoric that makes it a very binary choice. And I just don't believe it is.
Actually, I'm kind of going just mindful of something you said before I hit record, which was also about the need for different solutions, different tools, different roadmaps because of where people are situated, where industry is situated, the kind of actual geology and geography of our different environments. You articulated that really well, and I deeply wish that I'd already had recording going on. So I wonder, can you just revisit that, and then we'll sort of talk a little more about the market model before we wrap. But I think it's an interesting point.
Yeah, I mean, I think I had a chance to live in California, in Silicon Valley, and there's no winter there. They don't get snow. Like in the Canadian prairies, it could be minus 30 degrees Celsius. And so, the things that I worry about in the wintertime are the reliability of natural gas. And even when you go on a road trip somewhere, you got to make sure your vehicle is full of fuel, because if you hit the ditch when it's 30 below, you're going to need to have the vehicle running to wait until someone can bail you out of that problem. And so being sort of attuned to cold versus, say, in California, when I was down there, I really was for the first time sort of afraid of the heat. They got fire, they get all sorts of problems with heat down there. And so they have a different set of just sensitivities to weather, but then their energy mix can be attuned to that. So No one dies in California by freezing to death. It just, you basically can't do it because it just doesn't get cold enough, generally speaking. And so, things like intermittency and around their energy system isn't as life-threatening as it would be in somewhere like Alberta. And so that's just sort of a philosophical perspective. But California has a different set of resources. They've got incredible solar resources. They've got incredible wind resources. They've got a network of an ability to build networks of electrical systems because of the density of the populations. And so the solutions that make sense in California may be applicable generally to other jurisdictions, but there may be solutions that are created in other jurisdictions like Texas or Wyoming or Alberta that fit our circumstances in those jurisdictions. And carbon capture is probably one example of that, where you need to have sedimentary basins. You need somewhere to put the CO2. And so when you sort of zoom out and sort of ask your questions, well, what is like China going to do? What is India going to do? Because if we don't have solutions that will work for those countries, basically there's no way to solve the 40 billion ton a year problem. Because the energy loads and the emissions from the developing world are probably already greater than the developed world and are going to continue to grow. So as we sort of think about these sort of solutions, it's like, in China, they are natively rich in coal. And so are they going to just stop using coal? There's no way they're going to stop using coal in this decade or in the coming decades. And so what are the solutions that are available for coal that allow them to continue to use coal but not dump the CO2 in the atmosphere? That's also the case for India. What are the ways that India can use their natural resources, which are coal-based, and not emit? And so carbon capture, I think, can play a very important role in Asia in particular to solve problems. And that also applies in South America. So Brazil is a great example. So Brazil has an incredible quantity of biofuels. They take their sugar cane production and they turn that into ethanol. And their liquid fuel system in Brazil runs like heavily on ethanol. But of course, when you make ethanol, it's basically it's a pretty CO2 intensive process. And so again, carbon capture can play a meaningful role in Brazil in being able to reduce their emissions and continue to have their liquid fuel system be, operative and continue to grow. And so those are some of the, examples that just come to mind of, different solutions that make sense in certain jurisdictions.
I know we have a couple of clients, including Carbon Clean, who talk about CCUS as a service. If we sort of look at that and then look at what's needed next in general, what would you say there?
Yeah, so the business model of an emitter and sequestration, there needs to be some sort of capture process. There's a variety of solutions for those. And so, if you're depending on the circumstance or the company that you're in, there's a lot of interest in specific solutions. So if you're in the cement business, how are you going to solve cement with carbon capture? Of course, when we make cement, it's very CO2 intensive. Cement's 7% of CO2 emissions. Steel production, how do you create the heat in order to turn that ore into steel? I mean, it's incredibly energy intensive. And so, I think the message here is that there will be sort of emission capture solutions. There will also be substitutions to using more electricity, using more hydrogen. And so then the question is, well, where are you going to get those electrons and those hydrogens? And what's the process to create that energy carrier so that steel plant is able to use either of those choices? And so that's how you really need to, I think about it, is that there are, there's call it these point source capture solutions, and then there's the energy carrier solutions. And so each are a little bit different, but what it speaks to is just how broadly applicable this basic concept of carbon capture can be.
In the round then, when we sort of think about what's needed next for CCUS to be able to start playing its part at scale, I mean, I'm hearing you say from earlier in the conversation, it's a lot about solving that transport issue. What else what's your call to action? If you think about whether it's policy influencers or makers, whether it's industrials that might be a service user or other investors, what is it that you want, like the call to action for those people to consider?
Yeah, I mean, basically the transportation thing, it doesn't have to be a problem. There are many places where the sequestration can happen co-located with the emitter. So I just want to put that out there. It's not necessarily the case that you need to have pipelines, but sometimes you do. The biggest driver to carbon capture is price and value on carbon. And so as an investor, as a fiduciary, and I'm looking at $1 billion piece of equipment, I have to be able to underwrite that and have very clear, specific cash flows. So in the United States, the Section 45Q tax credit, pays $50 a ton for geologic storage. And so then it's over 12 years. So I know that if I were to do a 1 million ton a year project, then I know it's $50 million a year for 12 years. $600 million is sort of the number. So then I could figure out and say, okay, well, if I'm going to try to hook up on a hydrogen plant, a carbon capture unit, like retrofit an existing hydrogen plant, can I do that for less than $600 million? If I can't, then it's just uneconomic. I'm not going to do it. I will not be able to get the money to be able to do that, because the person who signs off on the loan or the equity investment is also a fiduciary, and the law holds them to have to see how the math actually works. And so the basic, and that's where the reconciliation bill in Congress right now is a very powerful thing. So it's currently on the books to move up to $85 a ton, and to have that be like a refundable tax credit from the IRS. So the IRS would essentially, send you a check for the $85. And so coming back to our example, that same 1 million ton a year project is now over $1 billion of economic value from the government, the United States government, in the form of cash. And so now I can look at it and say, okay, well, that hydrogen plant, it needed about $700 million to make it all go around. Now there's $1 billion of incentive. Okay, let's proceed with the project. And because it's economic, it's in the money. There's more economic value than the cost, and the capital will just naturally flow. I mean, that's the magic of capitalism. If you show a return to the market will quickly figure it out and do the engineering and the permitting and build this stuff. And so that's just first and foremost, is that a value on avoided emissions, a value on a price on carbon is the key piece of it. And we're moving towards that globally in the developed world. And I think that's exactly how we should be thinking about it, is rewarding people who are solving the problem. And so I'm very encouraged that the conversation is going towards carbon pricing.
Great. Well, Craig, I'm really appreciative of your time today. I think it's so important for a company like ours. Yes, we focus on decarbonisation all the time, and it's very easy for those conversations to sort of start leaning one way. And I think having like the full range of data, views, it all feeds this, what we were talking about earlier, this kind of the healthy tension, the healthy discussions that actually round out better solutions as we move forward. So really, really appreciate your expertise and time. Thank you very much.
You're welcome. Thank you. And I would want to end on just one point, which is that for me, some of the most satisfying conversations have been with folks that are deeply committed to environmental solutions and are struggling and really wrestling with sustainability problems, because we actually are sharing a commonality as to, okay, how do we solve the problem of emissions? What are ways that the industry can contribute to that? And that's where I found the richest and most rewarding relationships and conversations. So I very much appreciated having the opportunity to be here and talk about this today.
Great, thank you. And we're coming to the end of the year, so happy holidays too.
You as well. Thank you, Alex.
Many thanks for listening to the Decarb Connect podcast. We work with clients across the industrial sectors, specifically those who are tasked with decarbonising the most energy-intensive products and materials that we use every day. If you have an interest in learning more about either our members network, our reports, or our event series, do get in touch with us at decarbconnect.com. Or if you'd like to take part in the podcast, email me, Alex, at ac@decarbconnect.com. Thanks for listening.